Hey everyone, today we are going to be talking about numerical expressions or using the order of operations. This is one of my favorite lessons. A numerical expression is a combination of numbers and at least one operation. To evaluate a numerical expression means to find the value of the expression or find the quote-unquote answer. Okay. The order of operations are the rules that we follow when more than one operation is being used. Without these rules, everybody would be doing these operations in whatever order they felt like, and everybody would be getting different answers. So some of us might be getting the same one, some of us might be doing it completely differently. So in math, they have given us these set of rules called the order of operations that we must follow when evaluating numerical expressions to ensure that we all get the same answer when we do it the same way. We are going to call this GEMDAS. So the G stands for grouping symbols. Okay, and our grouping symbols are going to be things like parentheses, brackets. We can use these curly brackets. I think that might be the extent of what we see. But all of those things pretty much mean the same thing, that we're grouping these operations together. The reason why we talked about exponents is because it is part of our order of operations and we have to know how to evaluate them. So exponents come next. Then multiplication and division. From left to right. And this is super important. As we are traveling through our expressions from left to right, if division comes first, that's what you should do first. Okay, it's multiplication and division. They are equal operations to each other. We do them from left to right. Same thing with addition and subtraction. Okay, those are considered equal operations, so we do them from left to right. One thing that we do need to talk about before we move into some examples is how do you know when to multiply? You are going to know when to multiply when you see a dot. So 2 times 3 is multiplication. You are going to know when both numbers are in parentheses. You are going to know when one number is in parentheses. At this point, you are very rarely going to see the X for multiplication. You are going to see a lot of the dot because as we move forward in this module especially, we're going to start using variables, and X is a very big variable that we use. So you're not going to see that X for times as much anymore. Okay, so just so we understand that. So in our examples here, we're going to kind of go in order of like difficulty. So we're going to start with just left to right operations. Then we're going to add a little bit more. Then we're going to add a little bit more. So in number 1, I'm working from left to right because it's subtraction, then addition. So I'm going to do this first. And you'll notice that I've got some lines written here. That's because that's the number of lines you are going to use to show your work. So 24 minus 8 is 16, and I'm only changing that one thing. And then I'm going to do 16 plus 6, and I get 22. Should only be 2 lines there. Don't know why we have 3. Number 2, very similar looking problem, but this time my addition comes first. And again, I'm going from left to right. 32 plus 16 is 48, and 48 minus 2 is 46. Okay, so that's addition and subtraction from left to right. 3, 4, and 5 are our multiplication and division from left to right. So here I'm going to multiply 15 times 2 is 30 divided by 6, and 30 divided by 6 is 5. 48 divided by 3 is 16 from left to right. 16 times 2 is 32. 16 divided by 4 is 4 times 3. 4 times 3 is 12. Last one is going to be back to addition and subtraction. So 63 plus 12 is 75, minus 15 is going to be 60. Okay, you can see that I underlined the operation that I was doing. I wrote my new line with that change. That's the only thing that changed from each step, and then my final line should be the answer. 1 through 6 here should all have only 2 lines. I'm not sure why we included a third line there. In example 2, it says using MDOS, so multiplication, division, addition, subtraction from left to right. So in this one, I'm going to start with my division because division comes before addition and subtraction. So my first line is going to be 15 plus 2 minus 7. Then I'm going to do my addition because that comes first. So 17 minus 7, and 17 minus 7 is 10. In number 2, I've got multiple sets of multiplication and division. So I've got division first, then multiplication. So again, left to right. 99 divided by 11 first is 9 plus 8 times 2. Then I'm going to do 8 times 2 is 9 plus 16, and 9 plus 16 is 25. The next one, I've got multiplication here in the middle. So 16 plus 8 minus 3. Addition first because it comes first. 24 minus 3 is 21. Here division is first in the middle, so 12 plus 2 minus 2. Then I add 14 minus 2. Then I subtract 12. Example 3, we're adding in the entire thing. So starting with our grouping symbols, adding in some exponents, multiply, divide, add, subtract. So in number 1, I have these grouping symbols right here. So these parentheses are what's going to come first. So it's going to be 20 divided by 4 plus 17 times 3. Then from left to right, division comes first. So 5 plus 17 times 3. This is one of those rare examples where they're using the X for times. So 17 times 3, 5 plus 51 is 56. You can see that I'm using every line. In number 2, my exponent is going to come first. Remember that this exponent means 6 times 6. So this is 3 plus 36 plus 4. And then I'm going to go from left to right. So 3 plus 36 is 39, plus 4 is 43. In number 3, I've got these parentheses. And then inside the parentheses, I have an exponent. So I'm going to do that first. So 5 plus 64 minus 2 times 2. Remember, this is 8 times 8. And then I'm still in my parentheses. So 5 plus 62 times 2. Now I can multiply. 5 plus 124 is 129. In number 4, I've got those parentheses again. So 25 times 3 divided by 5 minus 12. And this is a good example. That's like the very first ones that we did where there's multiplication and division. And then how do we know what to do first? Well, we go from left to right. So 25 times 3 is 75 divided by 5 minus 12. 75 divided by 5 is going to be 15 minus 12. And then 15 minus 12 is 3. On to some more on the back here. I'm going to do my parentheses first. So again, grouping symbols first. So 19 minus 13 is going to be 6. Nope, just kidding. That's not right. That's 19 minus 19. And 19 minus 19 is 0. Now number 6, a little bit more complicated. So I've got multiple sets of grouping symbols. You're going to go all the way to the inside first. So I'm doing this set of parentheses first. And inside that grouping symbol, I have an exponent. So I'm going to do this before everything else. So 4 times 4. So my bracket is going to stay 12 plus my parenthesis is also going to stay 36 minus 16 divided by 2. So I'm keeping everything the same except for the one thing that I'm changing. So I'm still inside these parentheses to start. So 12 plus 36 minus 16 is 20, and then divided by 2. And then now I'm inside these brackets. So 12 plus 20 is 32, divided by 2 is 16. And then they just use the square brackets as opposed to the parentheses to kind of separate where those brackets and parentheses are. So like, where do these grouping symbols begin and end, and then where do the inside ones begin and end? In number 7, we're starting with these grouping symbols. Oh, I highlighted too far. We're going to start with these grouping symbols right here. So I'm going to start by adding 4 plus 6. So 5 parentheses 10 minus 7 times 7. This is multiplication. So 5 times 10 is 50 minus 7 times 7. 7 times 7 is 49, and 50 minus 49 is 1. Number 8 is very similar to number 7. So I'm going to start with these parentheses right here. So 6 times 11 minus 3 times 8. I'm going to multiply here first. So 66 minus 3 times 8. 66 minus 24. And 66 minus 24 is 42. Number 9, again, we're going to start with our grouping symbols. So 6 plus 4 first. So 100 minus 3 squared times 10 plus 2. Again, I'm only changing one thing at a time. Now I'm going to do my exponents. So 100 minus 9 times 10 plus 2. Multiply. So 100 minus 90 plus 2. Left to right, subtract is 10 plus 2, and then 12. In number 10, I've got some grouping symbols, and then within those grouping symbols, I have an exponent. So I'm going to do that first, 8 times 8. So 5 plus 64 divided by 2 over 5 times 2. And then inside my parentheses, I've got this fraction division, so I'm going to use a line for that. So 5 plus 64 times 5 over 2, and I'm actually going to erase and change that really quick. I'm going to change this to a 64 over 1 times 2. So I can cross cancel. This is 32. This is 1. So 32 times 5 is 160. So this is 5 plus 160 times 2. Multiplication, so 160 times 2 is 320. And then 320 plus 5 is 325. So that one was a tricky one with the fraction division, but that is something that we do know how to do. We keep change flip, so put that 64 over 1 and then change the fraction, or change the multiplication or division to multiplication, and then flip that fraction, cross cancel. Here at the end, I'm going to be inside this grouping symbol right here, and I'm going to be doing my exponent first. So that's 2 times 2 times 2. So my bracket stays 23 minus 8 plus 8 times 2 plus 10. And then I'm inside here still, so 8 plus 8 first. So bracket stays 23 minus 16 times 2 plus 10. Now I can do my 23 minus 16. So I'm in this parenthesis right here. So that's going to be 7 times 2 plus 10. Now I can multiply. 14 plus 10 is 24. Okay. Now the tough thing about order of operations is we can kind of make up any kind of numerical expressions that we want. We can include whatever parentheses, brackets, exponents, multiplying, dividing, adding, subtracting. I can make up infinite number of problems to practice with these. The most important thing is that you're following the rules, that you're following order of operations. Okay. Because all the problems are so different, we can make up ones that are similar, but we can also make up things that are insanely different, and we can be as simple or as complicated as we would like. So we're going to be practicing order of operations for a while to simplify these numerical expressions, to make sure that everyone understands the rules and knows how to follow them.